Hello and welcome back to my channel. In this video we will be talking about friction. So friction and how we use it in the real world is often all around us. It is all around us actually on a daily basis. We talked about it previously when we first did the introduction to this unit and forces, and we talked about friction and how it applies to our free body diagrams. But let's talk about a little bit more about friction because there is two types of friction. But first, what is friction? Well, friction, again, is the force that opposes motion, right? So it's the opposite force of a force applied. Remember, forces do not come in single or odd amounts, they come in pairs. So it's the force that opposes the force applied. So when you talk about the two types of friction there is a static friction and there is a kinetic. Pardon me, let me rewrite that. Kinetic friction. So there's two types of frictions. What's the difference? Well, static friction prevents an object from actually moving on a surface. So static friction is friction that prevents an object from moving. So it's basically just what the thing is that prevents an object from moving. Let's say you had a fridge that you want to start moving. Well, the thing that stops you from actually just moving around freely is static friction. You might notice that before you start to get it to move, it's really hard, but once you start to get it to move, it's not as hard. So we understand the thing that holds it from actually moving in the first place to be static friction. Like if you have a laptop on your desk and it's not sliding around, you can understand what's holding it there is static friction. So the other type of friction we have is then the opposite, or what comes after static friction, which is kinetic friction, which is friction that slows things down from moving. This is basically just a friction that slows things down from moving. Similar to how you may move your pencil across your paper, and you may notice that's not fully gliding because it still has some resistance. Well, that's kinetic friction stopping it from moving. Well, just for fun, if you want to think about it, what type of friction do you think is greater? Kinetic friction or static friction? I'll let you think about it for a little bit. But if you're wondering which one is greater, well, similar to how it's harder to push a fridge to get it moving than it is to keep it moving, or how it's harder to get a box moving than it is to keep it moving, that's because the static friction is usually greater than the kinetic friction. So static friction is usually greater than kinetic friction. That's just something that we can keep in mind when we're working through some of these problems, and just something that will come in handy sometimes. Now, the next thing I want to talk to you about, is the symbols for these. The symbols for static friction are just Fs for friction static, and the symbol for kinetic friction is just Fk. Right? So those are the symbols you can use. That'll come in handy. Now we can go into the next part that I want to talk about. The next thing I want to talk about here is the coefficient of friction. So of friction. Now you may ask, what is a coefficient of friction and why does it apply? Like, what is it useful for, right? Well, the coefficient of friction is the amount of friction in a way acting on an object, right? So if we want to find out what the force of friction is, we have to multiply the force of friction by the force normal of an object. The coefficient of friction is just, in a way, it's how much of a friction there may be. It's harder to really think about it conceptually, but the coefficient of friction is simply something that is always present. The coefficient of friction will change, really. It really depends on the mass of an object and what surface it's on. That's what the coefficient of friction really depends on. But it's used all throughout this part of the course. So the symbol for the coefficient of friction is just mu. You may have seen this before, the mu sign, but here we use it as a symbol of coefficient of friction. And the formulas that we will use for friction are going to be Fs or Fk is equal to mu times Fn. Now, this is the symbol, the formula we have for friction. From here, obviously, we can rearrange to find Fn, we can find mu, we can find Fs. These are just simply by rearranging the formula. We can divide by Fn. We'll get Fs over Fn is just equal to mu. We obviously know Fn can equal mg, depending on some things, if all the forces are balanced. There's a lot of things we can do here with this formula. And again, the formula for force kinetic or friction kinetic is just mu times Fn. It's the same formula for both, just depending on what you have as your variable. Nothing really changes. But now that we understood those concepts, let's move into some example problems and trying to work with the coefficient of friction. Okay, we can take a look at this practice problem and see what we can do. A box of mass 10 kilograms is placed on a horizontal surface. The coefficient of static friction between the box and the surface is 0.4. What is the maximum force that can be applied horizontally to the box without causing it to move? B, if a force of 35 newtons is applied, will the box move? Explain why or why not. So you may notice in this question that there's no really unit with our static or coefficient of friction. You may wonder why. Why isn't the coefficient of friction, why isn't there any units with the thing that we're given? Well, the coefficient of friction actually doesn't have a unit with it. It's more a measurement, really. So it doesn't really have a specific unit like mass or Newton may entail, like force may entail. But we can continue. So let's get into our given. So we know a box of mass, we can just go ahead and set right as positive, even though there's no direction. It's still a good habit to set something, our direction is positive. So a mass of 10 kilograms is moved on a horizontal surface. The coefficient of static friction between the box and the surface is 0.4. So we know that mu is 0.4. We know what gravity is, 9.80 meters per second squared. And what else do we know here? So what is the maximum force that can be applied horizontally without causing the box to move? So we're required to find, we're looking for Fs. Now, why are we looking for Fs? Well, we're trying to look how much force can we apply without having the box to move. And to understand and how to know how much force we can apply without having the box to move, we need to know how much friction there is, or how much force that requires the friction to stay there, right? So if we just go to our analysis, we know that Fs is equal to mu times Fn. Well, we're not given Fn here. So let's draw a free body diagram. We know that there's going to be a Fg and an mg. Pardon me. We know there's going to be a Fn and mg. Fn and mg, which is equal to Fg. Correct? So we have all that. We know that it's moving around along a horizontal surface, but because we know that there's no acceleration in the y direction, it's moving along the x, correct? So there's no really acceleration in the y direction. So we can put such that there's no acceleration of the y is just equal to 0. Because we know it's not moving up or down, so we know that the acceleration of the y is 0. So we can put Fn is equal to Fg. So now we have what Fn is, because it's just Fg. So now we can just put Fs is equal to mu times Fg, force of gravity. Now that we have this, we can just sub in times mg, mass times gravity. And now we can just go into our solution. So force of friction static is equal to 0.4 multiplied by 10 kilograms times 9.80 meters per second squared. Now that we have this is just calculator work. So this ends up being 0.4 times 10 times 9.8, which is equal to 3.9, 39.2 newtons. And according to significant digits, because there's only one significant digit here, we should round off to one significant digit in our final answer. So our Fs is equal to 40 newtons. So now we can look at part B, because now we know that this is the maximum amount of force that you can apply without having it move. Because if you apply even 0.2 newtons of force, the box will start moving. This is how much force is keeping the box there. So if a force of 35 newtons applied, will the box move? Well, in this case, because we already know, this is more like a conceptual thought process or analysis. It says, like, will the box move if 35 newtons is applied? Well, we already know that the force applied in this case is 35 newtons. And the force of friction that's keeping it there is 40 newtons. So 40 newtons is obviously greater than 35 newtons, which means that if you do not apply at least 40 newtons of force, the box will not move. Therefore, for part B, the box will not move because the force of friction is greater than the force applied. Well, that's all for this video. I hope you got a better understanding and grasp of what static and kinetic friction is and how we can apply it to simple questions like this. Again, this can also be applied maybe if, say, we had a force applied here, if we were actually given a force applied, and maybe we were also going on an incline. Maybe if we have a pulley here, we could be using coefficient of friction there too. If we had a pulley system here, we'd have maybe a force applied here, force of friction here. Then we'd also have again, force normal here, force of gravity here, force normal up here. We have all these things that we can consider when we're using force of friction, but remember that these are the key concepts when it comes to friction and really the whole concept of kinetic and static friction. We can apply them, we can rearrange, and usually if it's only moving on a horizontal surface like this, if we're only going left and right, well then we can assume that the acceleration in the y will just be equal to 0, correct? Because the box isn't getting an acceleration up or downwards, so we can assume it to be 0. Therefore, we can set Fg equal to Fn in case we don't have Fn sometimes, because you won't always be given Fn. So sometimes it's just easier to sub in for mg. That's just a simple rearrangement that we can really work with, and that's something that will come in handy the more and more we use it. But that's all I have for this video. In the next video, we'll be discussing maybe a little bit more about forces. But that's all I have for this video. I hope you enjoyed it. And remember, physics rocks.